Good evening, everyone. Myself, Shweta Dhanda. It's my privilege. It's my privilege to address you all on the behalf of Dollar Education. I welcome you all in free online seminar series on research and career journey in bioinformatics. We are truly delighted with your presence. Our organization, Dollar Education, is an initiative to offer practical trainings on emerging concepts by making them affordable for all and developing a consistent environment of growing together in the field. We want to promote bioinformatics in the field of biology. The concept is just to connect and share. The concept is just to connect and share ideas amongst various groups. We named our organization because it is a popular as an affordable symbol and used as a variable in computer language. You can find us on social media with Dollar Education to keep us all in touch and also share ideas amongst each other. Today, I'm pleased to welcome Dr. Laura Harris again, who is a senior bioinformatician, Neuro X1, to share her experience and her journey herself today. She has completed her Bachelor of Science in microbiology and Masters in Microbiology from Michigan State University. She also pursued Masters in Cellular and Molecular Biology from Michigan State University. She has completed her PhD in Biomedical Informatics from Rutgers University. Talking towards her experience, she has worked as a scientific laboratory coordinator and also worked as associate scientist at Bioport Corporation. She's also worked as scientific project associate at Pfizer and RA at MBA International. She's also a medical writer in MMS and a lead faculty in AHR Science Health in University of Phoenix. Now she's a senior bioinformatics scientist in Neuro X1. She has added a remarkable awards to her credit that are Teacher of the Month by Rasmussen College in December and also awarded with the Excellence in Teaching Award by Davenport University in August 2018. Now, we are excited to see her career path and get inspired. Now, I request Dr. Harris to take the session further. Ma'am.
Thank you very much for the introduction. Just give me a second to get things set up here. Awesome, we should be good to go. So welcome back. My name is Laura Harris, and today I'm actually presenting a different talk than what I'm used to presenting. It's definitely going to be less research and more personal. So my talk today is my journey to success of bioinformatics story. And so if you want to reach out with any questions after the session, my email address is here, and I'm also available via LinkedIn, so that's listed there. So why should you listen to me? Well, as already stated, I'm currently the senior bioinformatics scientist at a startup company called Neuro X1. I've been there for a very long 6 weeks. Prior to that, I was at Michigan State University, Davenport University, University of Phoenix, Rasmussen College, Pfizer, Bioport. I'm going to be going on. But anyway, right now, I'm also the founder and principal investigator of the Harris Interdisciplinary Research Group. I started that group at Davenport University and I'm continuing that. And I'm also the Michigan branch representative for the American Society for Microbiology on their Council for Microbial Sciences. So basically, this is a small board of scientists that advise the society on how to act, how to help with legislation through the US Congress, how to do public outreach, how to assist things like the CDC or other public health agencies in pandemics, and all sorts of other cool things. So how did I get here? Well, this is a really short timeline. And what you'll see is that I started back around the year 2000. So that kind of gives away I've been at this for 20 or so years. I got my bachelor's of science in microbiology from Michigan State in 2000. Now the blue line represents anything I was doing in experimental biology. So this could be in a petri dish or in an animal, or in some regards, clinical writing, though I never actually got my hands on a patient by myself. The red line represents anything that is computational. And the black line is anything that's instruction. So you'll see I started out working in experimental biology. I then transitioned into teaching with bioinformatics for a while, back to experimental biology. Got my master's of science in microbiology in 2003. And you'll notice that that was a split thesis between a bioinformatic approach and an experimental approach. Continue on for a while doing experimental biology. Get my master's of science in cell and molecular biology. That was looking at inflammatory bowel disease and how it affects pediatric bone formation in mice. Then I started switching into instruction, and you see for several years I went on as a biology instructor, various places, and we'll talk about that. Then you'll see an addition to my instruction, and that is return to bioinformatics, where then in 2020, I got my PhD in biomedical informatics from Rutgers University. And as you can see from the coloring, that was also a split dissertation, part computational, part experimental. So now I continue on in bioinformatics only. So where did I start? As I mentioned, back in 1999, I was a student at Michigan State University. I started actually as a major biochemist, and then just had this really interesting intern experience at William Beaumont Hospital in Royal Oak. And you have probably seen me on LinkedIn, if you follow me there, talking about some of those experiences. But long story short, my major got misread, and they thought I was in microbiology when I was technically in biochemistry. So my first internship at the hospital, I was split between radiology and infectious disease, because that's what they thought I was, and I was interested in medical school. And after that experience, those 3 months over the summer, I managed to get a project going that was publishable. And so then I went back in the fall and decided, well, apparently I'm good at infectious disease. I'm just going to switch my major. So before ever taking a microbiology class, I accidentally got shoved in a microbiology lab, which was cool. I like petri dishes. And so I went to MSU. That then got me to, and with Dr. Julie hired. And he was a professor of one of my undergrad classes, prokaryotic physiology. It was an interesting class, but he was a more interesting professor because he was one of the few professors back in the early 2000s that was interested in computational biology. And his computers compared to today were slow. He would frequently have the covers off to keep them from overheating. They were programming in Linux. It was very interesting to be in that lab because the thesis started experimentally, but then switched into computation, mainly because of his interest, my interest, and some shifts along with what the thesis requirements were. So that thesis looked at basically genes in archaeal bacteria, nothing related to medical science. But it taught me things like BASIC and Pascal programming. So then I got my new combined degree, a bachelor's in science, both in microbiology. And then I went to work. So my first job was Bioport, now called Emergent Biosolutions. They have a decades-long history developing the anthrax vaccine for the US military. So I was hired into research and development, and I was tasked with helping them improve the efficacy of their vaccine, limit side effects, make it more effective. And so at that point, I started my career there, went on for a couple years, progressed on to Pfizer. Now, Pfizer, I switched from a petri dish to more of an animal model. So I was in preclinical dermatology as their scientific project associate. Our champion animal was a pig. They were cute, they were small, you could fit several of them in a pen, and their skin is very similar to human skin. That's why we used them. But it's huge. So I got exposed to scientific project associate who I'm still friends with that was looking at neurological drugs. I had a different friend of mine, same position, who was looking at cardiovascular drugs. So I got exposed to not only all different aspects of human medicine and drug development, but also the different animal models that go with them. So at this point, I had switched my focus really from medical school to attending graduate school because I have my master's, but I didn't have a doctorate. And a lot of the study directors I saw in industry had at least a PhD. Some of them had PhDs and DVMs, which is a veterinary medicine degree, or they might have PhDs and MDs, which is medical doctor degrees. They were doctors and I was not. So I decided to leave Pfizer at that point, which was really hard because I love working in industry with pharmaceuticals. And I wanted to go back to get my PhD. So I became a graduate assistant, trying to work towards my PhD in cell and molecular biology at Michigan State. But then children happened. And I have this quote here from Elon Musk that says, once you have a family, you start taking risks not just for yourself, but for your family as well. And it gets much harder to do things that might not work out. And that is incredibly true. And it definitely changed the trajectory of my entire career. So I have this picture here, and it's me coming home from the PhD lab. And I guess, as was very common, I would come home 8, 9 o'clock at night, and I would just pass out on the couch. I'd fall asleep. And my husband would do a lot of the childcare because he wasn't a doctor in training. He had a regular job. So, 8 to 5, he could be home taking care of our kids. So here's a picture he took, and he said, this is how he frequently saw me just come home and go to sleep and get up and go back at it. And years went on where that wore me down. I began wondering, am I really doing justice to my career? Am I doing justice to my family? Am I doing justice to myself? And so I decided at that point to drop out of the PhD program, the second master's, and that began the biology teaching days. So I started out as an online adjunct teacher, and I started at University of Phoenix in 2009. Was getting much more sleep, able to spend much more time with my family, pay still sucked, but I at least was feeling like I was contributing to society. And University of Phoenix then made me lead faculty area chair of their health area and their science area. And then I started traveling around locally throughout my state. I oversaw 14 faculty across the state, would visit them, hire them, sometimes have to fire them, and of course teach. I then decided to add in Rasmussen College as an online adjunct teaching experience to try to get more money and get more into the field as the kids grew. Eventually, that led to a position at Davenport University as an adjunct in-person teaching professor. And then Davenport hired me in full-time. And then I had to let go of everybody else because now I'm a full-time instructor at a legitimate teaching university. So I'd never been a full-time instructor before. It was always a part-time class here, part-time class there. So I asked, what are my responsibilities? What do you expect out of me? And I was told that my primary responsibilities were to teach 24 or more credits per year. So that meant 5 classes in the fall, 5 classes in the spring, and typically 2 to 3 classes in the summer. That also meant preparing for the laboratory classes. So having the reagents made, making sure the pipettes are autoclaved and ordered, and all the stuff is available for the other adjunct instructors. But then if I wanted promotions, if I wanted to become an assistant professor or a full professor, I then had to add some things. So I needed professional responsibility, which meant publishing papers, talking to audiences like yourself or at conferences, etc. And the terminal degree. I need to become a doctor. So I started looking around at my fellow faculty members, and I noticed that most of the instructors had either earned their PhD in education field or they had gotten their doctorate as an ED, specifically in education. And that was because Davenport was a teaching college. They didn't have research. They weren't getting National Science Foundation grants. So the faculty were aligning their degrees according to what Davenport wanted. But remember, way back when I was at Pfizer, I went to graduate school to get a PhD so I could become a study director. I wanted to lead and teach research. I didn't want to know how people taught and learned. I wanted to just give the material and they taught and learned on their own. So that changed my direction. So I got PhD in biomedical dissertation to predict targets for Staphylococcus aureus, MRSA. But you saw what that branched into with SARS and cancer on Tuesday. But it all started with Harris Interdisciplinary Research. So while I started my PhD, my students at Davenport were seeing me start my program, and they saw the enthusiasm that I had with what I was learning. And they said, hey, Laura, can we help you too? We want to get involved. But remember, Davenport isn't a research, they're teaching. So these are nursing students. These are computer science students. Then they started a science program. So one of the people you see here is actually a science major, but all the other ones weren't. They were just people that said, hey, I know nothing about computers. And I said, do you know how to cut and paste? Then you can help me. And we just built from there. And so here you can see me standing with several students several times with different posters at different conferences. We tried any project we could think of and took it in any direction that we could think of. And we tried to have as much fun as possible along the way. And then we found that those posters developed into talks. Those talks developed into papers. Those papers developed into national conferences and awards and hanging out with Nobel Prize winners. And it just became insane. So we experienced a lot of growth just from doing what we were passionate about and what made sense to do with the resources that we had. And so prior to me even getting my PhD in 2020, I already was the president of the American Society of Microbiology for all of Michigan. I was the Michigan branch representative to ASM's National Council of Microbial Sciences. I had earned a Peggy Cotter Travel Award for early career ASM branch members. And these were just the awards that I had within my career. I was surprised when I started getting awards outside of my career. So Davenport's University Excellence in Teaching Award is only one of 3 awards given every year across the entire university. Awarded 2 Emmy Davenport Legacy Endowments. I found myself having discussions with the Davenport University board at least every 6 months. They continued to give me faculty research grants, and then they started bragging about what we were doing and the student involvement in conferences through their alumni magazine and in their posts. I was turning on the work computers at Davenport and my face and my students' faces would splash up on the screen. And I would just chuckle and be like, yep, it's gonna be one of those days. But then, I was nominated and awarded a feature for the Michigan Chamber of Commerce Lead Like a Woman. And then an honorary membership to National Society of Leadership Success, this Sigma Alpha Pi. This was actually a nomination from one of my students to be an honorary member. And I never would think of myself a Greek girl. I don't party the way the MSU Greek people do. But anyway, I guess now I'm part of a Greek society. But my students also succeeded when I succeeded. So they have countless poster presentations with me as senior author, as you slide. We had one national poster presentation, invited to one conference workshop presentation, 5 paper publications, all with these students who would have never thought to even look at a computer for research. They're now published authors. And then they got their own awards. Jessica was the Davenport Day of Research Student Keynote Address speaker. Amber got that award a couple years later. Christine was honored with the Best Undergrad Poster for ASM Branch. Kawana ended up as the student commencement speaker and was traveling with me to Washington, D.C. to do 4-hour workshops at ASM education conferences. So what I realized through the time I had at Davenport and building all of this, but doing it had been. And then of course, COVID happened. It's like the mic drop for everybody. We just say COVID happened and everyone nods their head going, yeah, great. Yeah, COVID happened. We all remember that. But COVID put a whole new light on being a study director because suddenly where everyone else's and my own momentum came to a halt, I was able to continue. Where people were shutting down labs and throwing out petri dishes and killing off their mice, I had a computer. I just had to get out of bed, take a shower, and come downstairs and just pick up right where I left off. So even during the pandemic, the fact I had switched from a wet bench to a dry bench, from a petri dish and mouse to a computer, made me pandemic proof, professionally speaking. So even during the pandemic, I continued to get grants and article features, and Amber, my science student, was now a senior who had worked with me for 4 years. So you could bet she's good. She's now in medical school where I really started, back in the day. But, she was winning 3rd place national prizes for our research. I said she had the keynote address. She was able to present her poster at the World Microbe Forum. And then, of course, 2 paper publications on SARS that we talked about on Tuesday. So, through this, I can continue to be a research director despite a global pandemic. So you might have remembered that there was a kid a few slides ago, kind of changed my whole life. Kids tend to do that. So you may be asking, so Laura, what'd you do with the kids? Did you put them in a closet? Did you hide them in the basement? Did you put them to work? Okay, yeah, the short answer is yes, a little bit. What'd you do with the kids? So the kids learned very early on, like 2015 when I started my PhD and really growing this. Mom is super busy. So before you ask mom about anything, ask yourself 2 questions. 1, can I do it myself? If I can, I should, because mom's gonna tell me to. If I need help, okay, bug mom. But I need to at least try. And I need to figure out where I need the help so mom's not trying to figure out what's going on. I can just say, hey, mom, here's my question. Here's where I need help. The second one is, do you want to help me? So I was frequently asking them, hey, can you cut and paste? My students are cutting and pasting. You can cut and paste. And so there are actual pictures sometimes on LinkedIn where you'll see memories of my kids sitting at the computer. And that's all they did for a little while was, okay, cut and paste. If I could cut and paste enough data, then maybe we can put something together. And so Serena here is my oldest, and I'll talk a little bit about her. So the family was impacted by my goals and my aspirations prior to me getting my PhD. Serena was already interested in computers and biology from watching mom work her butt off and cutting and pasting and asking questions. So she began working with the group in the spring of 2018. She presented her first poster, which is what you're seeing here, her next to 2 of my students also presenting posters, in March of 2019. And that was a huge experience, not only for her, but for my students and for the society. Because the students were super excited. They work with her. They know she does these projects. She can answer questions. The society does not. And the society tends to be a bunch of older people that are set in their ways that don't necessarily like change. And the younger generation is all about change, and computers are change. We need to embrace that. So it was very interesting for everybody, for her to attend. And she has a picture holding up a Women in Microbiology book that she was given as an honorary presenter. But anyway, her poster was actually accepted for ASM microbes at a national conference. But it was scheduled for June of 2020 and canceled because of COVID. So Serena had already started to become interested in my area from just being around. And then of course, COVID happened. So that started the kids now not only living with me, but studying with me. It became 18 months of they don't go to school, they're here. And sometimes there is no school. Mom, can you teach us something? And I still got to do work. I've still got to grade papers. I've got to write papers. I've got to conduct research. So the first question everybody started asking, when will the COVID? And Serena was fun because when she started asking, I said to her, well, logarithmic curve, growth curve, you've seen it. Why don't we learn the math behind that? You can use that to predict when we're coming out of quarantine. So her and I started this project where every day we'd go into the public health database and we would download the latest counts of cases and we were plotting. And then we started sharing that on Facebook so her friends could see it. Then one of her friends' parents was part of the news. They got it. Then they wanted to put it on the news. So then I'm on the news. Then they wanted updates on the predictions. Then another wave happened and they wanted more predictions. And before I knew it, the end of 6 months, I've been on the news 4 times about a project simply teaching her how to predict when we're going to leave. But it taught her math skills. It taught her programming skills. It taught her biology skills she still uses today. So she came out of this pandemic now. She's a 14-year-old about to be 15 in a couple weeks, excited for driver major at Lansing Community College. Finishing her first year, her GPA is like a 3.8, 3.9. And she's just finished a quantum computing class for high school students at the Massachusetts Institute of Technology, which is her dream school. So right now, she's super excited to get into quantum, and she wants to expand bioinformatics in a quantum realm, which is definitely exciting moving forward, because even I'm not able to do that. But then there was Lily, the younger sibling. Lily, prior to the COVID pandemic, was already starting at LCC and their Gifted, Accelerated, and Talented Education program. She was attending the National Young Leader Forum in STEM, Science, Technology, Engineering, and Math, at La Jolla University in Chicago. She did not like the dorms. She says she didn't get enough chocolate milk. She's now applying to the Michigan State University Gifted, Accelerated, and Talented Education program, and we'll see in a couple short months here if she gets in. That's for high school credit, where she actually could get out of high school by the time she's 16. And her goal right now is become a heart surgeon. So we'll see how that works out for her as she continues to grow. But the point here is that I realize I not only can be a good study director, I can also be a good mom, particularly when you combine them and you do what you like. So at this point now, I've got my PhD. Davenport was awesome, and I love them dearly, but they're a teaching college. They're not a research college, and I want to be a study director. And they weren't affording me the ability to do it full time. It was always on the side. So then I looked at Michigan State University. And I started last year as their director of training at the Institute for Cyber-Enabled Research, aka ICER. ICER is a supercomputer. And so it was really cool to work there because it taught me a lot about how to use a high performance computing cluster, something like AWS, if you're using it commercially. They did afford me some time, some paid time towards research, but I had a bunch of other responsibilities too, but 25% is better than zero. The challenge here became, what was research? So as you know, I had been doing bioinformatic research. Some of it was progressing into the wet bench at Davenport, but I wasn't getting paid for it. At MSU, they were going to pay me 25% of my time for research, but they quickly wanted that research to be education-based. How to further education of supercomputing and its uses, benefits, that sort of thing, which is a noble goal, completely cool, but not me. Because remember, my PhD is in biomedical informatics because I don't want to learn how people learn. So this job was awesome, and I greatly appreciate the experience, but it just didn't fit me. So after a year, my contract came up and I decided to move on. So 6 weeks ago, I started at NeuroX1. So NeuroX1 is a little startup company. I think we've got 7 people. And we are specializing in pharmaceutical discovery for neurodegenerative disease using artificial intelligence. So basically, I'm taking the algorithms that I've spent all this time developing and the ones that I haven't shared that are still in my head, and I'm creating approaches and analyzing the data to predict potential drug targets for anything from Alzheimer's through neurodegenerative diseases. We are small, we are new. So we're hoping to expand into the laboratory and clinical spaces once we get some more funding, and we're actively going through seed funding efforts right now. But this is a full-time position. As a senior bioinformatics scientist, I am now a full-time study director. I don't have to teach people if I don't want to. I don't have to do presentations if I don't want to, unless it's selling an idea or a product to a board or, a body. I do paper writing, but that's based on what I'm discovering here, again, to further what's going on for the sales part. So it's me basically coming full circle, because I left Pfizer back in 2004 with the idea that, was it 2004? It could have been 2006. Seriously, I've been here too long. I have fun doing it though. With the idea though that I wanted to come back and do full-time pharmaceutical discovery. And now I'm there. So my overall goal moving forward is to continue to grow and lead a culture that's focused on computational research and experiential learning. I firmly believe that our whole society fits when we integrate computers into our research. Being able to do that with biology, any part of biology, and computer science. So I'm really trying to bridge that gap, both from research standpoint at NeuroX1, and also through experiential learning, like the projects I do through the Harris Interdisciplinary Research Group, or through lectures like this, or the one on Tuesday, where I'm introducing you to things that you can then apply to your own research. So as far as I'm concerned, moving forward, the future is incredibly bright, particularly when I look at the next generation and what they're interested in, what they're passionate about, and where you all want to go in the future. And I'm honored to be a part of that. So that continues to be my ongoing journey to success in bioinformatics, and the hiccups and shifts along the way. If you have any questions, I'm happy to entertain them. But if you want to reach out to me after this, my email address is here, and then my LinkedIn account is there. So at this point, I'll take questions. Okay, I see a question popping up. Non-traditional PhD aspirant. Also left my previous PhD, but due to health reasons. And now I want to re-enter into research with computational biology. Yep. Question is, what should be the roadmap for women like me with a gap years and comeback? Okay, so I'll take one question at a time because there's more than one question here. What I did and what I recommend you do: identify your gap, skill gap, and fill it. So for me, I knew I was very strong in wet bench biology and clinical biology. I'm a biologist, but I wasn't really great at programming. When I went for my PhD, the programming experience was over 10 years old. The languages that they were using, I had never seen before. So I went and I found a Coursera class, and I think I paid $50 for it. It took me a few weeks, and it basically taught me how to use Python. Now, there are other places that I recommend besides Coursera. There's Pine Biotech and if Dollar Education. There's a few places, but figure out what your gap is and fill that gap. Once you have that gap filled, the years don't matter so much because then you can show progress, and that's really what they're looking for. So the next question, do you think my applications will be impacted by the gap years? Not if you fill the skill gap. People understand life happens. People understand you have older parents that you have to take care of. You yourself might get sick. A spouse might get sick. You may have kids. I mean, I had gap years that I filled with part-time teaching, but it still showed I'm active and I'm trying to progress. And that's just what you have to get out there. So I'm sure you could do it. I did it. Okay. Is it necessary? Short answer, no. One person asked on Tuesday a very good question. They were computer science background and they asked about shifting into bioinformatics. And my answer to them is going to be similar to the answer I'll give you. Find a biologist. So you've identified your skill gap. Obviously do some research on your own so you understand the biology, but you're never going to get a master's level understanding of biology on your own. It's just going to take too much time. So go partner with a biologist and talk to them about what do you do in the lab? What questions do you ask? How do you generate the data that I'm going to be analyzing? That matters a lot because there's different ways to generate the same data in the lab, and how they do it will matter about your computational results. So you need to find a partnership. And that is very difficult because I'll be honest, a lot of biologists, myself included, have what I call command line anxiety. I don't feel comfortable at a command line. I'd much prefer a point and click interface. But I know I have to be command line savvy. So just be aware of that when you're working with your biologist, approach it from a collaboration standpoint. Okay, so that's that question. Next. Now I have completed Masters of Science in Bioinformatics. Cool, want to do PhD. Okay, so what thing will lead me a professor in the future? Okay, so there are 2 or 3 main things that are looked at in terms of a professor position. Mainly productivity, ability to get funding, and ability to teach. So I think about a week ago, I posted on LinkedIn a table from a paper that I had found that was like a grading rhetoric cheat sheet for exactly what they're looking for professor positions. Check that out. But that's what you're looking for. For you basically need to come up with an idea that is novel, that you can sell. Now, you can sell that to anybody. You can sell it to industry like I'm doing. You can sell it to a government agency for a grant. That's what most academics do. There are nonprofits, like there's the Bill and Melinda Gates Foundation, and Mark Zuckerberg has a foundation. So, wherever you get money, the point is that you get money. That's what the university really cares about when it comes to making you a research professor. And that also was a limitation for me at Davenport, the grants they would allow me to go for versus the ones I wanted to go for. But anyway, so that's that. What should I do during my PhD career? Well, the short answer is going to be work your butt off. Don't limit your options is going to be my biggest thing to you. A lot of people get in, they end up doing a dissertation on something, and they get hooked up on the dissertation so much that they don't see past it. You need to have a dissertation that is a case study. So like me, for example, with my dissertation, I developed an approach and I applied it to Staphylococcus aureus. But that approach hadn't been used before in very many areas. So it wasn't hard for me to just take that approach and apply it here, apply it there, apply it to cancer, apply it to SARS, apply it, you get the idea. So you need to have an idea that's going to be that flexible. If you only have one outcome, I developed this molecule, that's it. There's not much you can do with that other than the molecule, unless the approach is novel in itself, and then you can do what I did. So don't limit yourself, think broadly, and keep on multiple projects too, because you never know which one's going to pan out. Okay, what schools accept international students? I have no idea. That's what Google is for. What job opportunities are open for those? Again, that's what Google is for. I also recommend LinkedIn Jobs for that sort of thing. Can anyone with an MS in bioinformatics go into public health policy? Policy? Yeah. So I guess my backup question, if you're thinking public health policy, is what end are you going after? Because I'm only involved in public health policy from a data advising standpoint. So when the Congress comes to ASM and asks ASM, do we require masks? I'm part of a group that will then generate or analyze data and provide that data to basically be like, well, if you don't, here's the outcome. If you do, here's the outcome. And then hopefully use that data to lead them to the conclusion of what you want them to do, what they should do, what's in the best interest of public health. That doesn't always happen because politics are politics. And that's public health. So you're going to need to also partner with your people that are very good with persuasion, that aren't necessarily data driven. As I said, it's a team. That would be the only connection I see between bioinformatics and public health so far. There is now the environmental side though, so don't forget that. Without a fellowship, I will do PhD. So is it a fall in? I don't understand the question, Rogerline. If you could rephrase that, that would be awesome. Okay, PhD postdoc, assistant professor, cool. I'm lacking in silico computer science. Yep, wants to learn. People looking for, yeah. So for you, I would recommend Pine Biotech. Assuming that your place where you are an assistant professor doesn't already have a program. I was surprised that Michigan State University did not have a degree granting program, but they did have classes for graduate and postdoc and professors around bioinformatics. So, check out your university. You may have a colleague or what have you that's in that area that could help. Otherwise, there are places you can go for the certificate option. That's what I would do. We can help you. Oh yeah, dollar education thing. Thank you. I appreciate that. How do I just, well, that's up to you. What are you interested in? See, I picked Staphylococcus aureus for two reasons. One, it was a microbe that's antibiotic resistant, and I personally think antibiotic resistance is almost as deadly as global warming is going to be. So that's why I picked it. And then two, I specifically went after Staphylococcus aureus because I had made a promise to my mother-in-law who had a hip that was infected with MRSA that if I ever had the chance that I would look into it. So it just seemed, okay, I want antibiotic resistance and it's my background. She wants me to look at this. I need a dissertation. There you go. That's how I did it. But, since then I've applied it to E. coli, I've applied it to Pseudomonas, obviously to SARS. Never thought I'd be a virologist until SARS. So yeah, don't limit yourself. Whatever you're interested in, go for it. All right. I will do PhD without fellowship. Okay, I don't think so. So a lot of people do a postdoc after their PhD. And you'll notice from my background, I did not. And that has been a very interesting catch-22, because in academic circles, like if you want to go for a professor, they kind of act like you need a postdoc. But as you saw, I became director of training at Michigan State University, no postdoc. And I applied to postdoc positions when I got out of my PhD program, but I was already an assistant professor with a partially funded lab. So the people that were hiring for postdocs were looking at me and laughing, going, "You're already an assistant professor with a partially funded lab. Why do you want a postdoc?" And so I just never did and have not needed a postdoc. So again, I go back to skill set. If you can prove that you can do what you say you're doing and it's strong and convincing, people will overlook the lack of a formal education, so to speak. There's the infamous story about Bill Gates dropped out of PhD and, now he's got Microsoft. So, lack of a formal education doesn't necessarily mean anything unless you're not really able to put your money where your mouth is, as the Americans say. Hope that answered your question. Thank you for clarifying it. Waiting for any other questions.
Hi, Dr. Harris. I will ask one.
Yes.
So this is Sandeep, and I really like listening to your inspiring story, and I hope like many participants could relate to it. Thank you for sharing this story. And it was really like kind of going from research background to the teaching and then back to research and now to industry. Like, how did you manage to switch all this? Like there are a different type of skills that you might need while you are teaching, like the different type of skills that you will need when you go into research, and industry might be looking for a very different kind of skill set. So how did you connect that all the dots in here in a single journey?
I think the easiest way to answer that question is to stop viewing them as individual dots and incorporate them as one lifestyle. So research is research. At the end of the day, I'm still at a computer doing my programming and my predictions. Doesn't matter if I'm in industry or in academia. Yeah. I still got to get money. And yeah. I still have employees that I have to train on the idea that we're doing and to work with in collaborations for various things. So I would say that the skills in that regard are very easy to transfer between academia and industry. The only thing you have to be aware of is the change in pressure. There's not as much pressure to get things done quickly in academia that there is an industry, because you're always being competitive. But if you're 100% honest and you're working at a Nobel Prize winning level, those people are already under the same pressure that industry is to get things done fast and get it done right, because you have a competing lab that is at your heels instead of a competing industry partner. You know what I mean? Yeah. So again, completely transferable. And then the teaching part was just something that for me came a bit organically through my kids, because they're asking questions. If they're asking questions, that means I'm teaching. And so then it doesn't seem much of a difference to me whether I'm getting a question about how do I start the microwave versus how do I start the autoclave, so to speak. How do I start this program? So the teaching part is, again, another people skill that to me is completely transferable. It's just a matter of who am I teaching and when am I teaching and what am I doing it. So yeah, I would look at it more as a unified lifestyle. Figure out what your goal is and how you think you're going to get there. And then, of course, deal with the hiccups along the way. Don't think you need to have a subset of teaching skills and a subset of research skills,
Yeah.
meld them.
Yeah, the other question is about like how are you still continuing this Harris Interdisciplinary Research Lab?
I am to some extent. So right now, I have several students that I had from last year that I was working with through MSU. They're finishing out their projects and papers, and I'm starting to rethink the whole concept of hereditary, because I do see a need and get a lot of requests for doing research projects.
Yeah.
The challenge I'm running, the challenge I'm running into is there's only one of me, and I have a full-time job doing research that I now have to do also. So this is why I'm trying to partner places like Dollar Education, because if people come to me already having the gaps filled, it's easier for me to say, okay, go to my GitHub, do this and that, tell me what you find. And if I can take more of a higher level approach, then it's a lot easier for me to deal with more people. So there's that. I'm also thinking of getting Harris Interdisciplinary Research its own nonprofit status. So then that way it can have its own funding, and frankly, I can hire someone to help me in that area. And so once all those ideas are kind of thought out, hammered out, that sort of thing, then I'll be publicly going more broad stream.
Yep. And there is also another question from Surbi in the chat. So should I read it for you, or?
I'm trying to find it.
Yeah, the second last question.
I don't see a question mark. Oh.
Yeah.
Would you recommend, while writing a grant, utilizing publicly available data and or collaborating with a biology lab submitting grant? Short answer is all of the above. So when people go for grant reviews, like people sit down and read your grant, they don't care where the data came from unless you are saying you want money to generate data. Then they care where the data came from, because they need to know you can actually create the data you claim you can create that they're going to give you money for. Remember, people are pretty simple when it comes to grants. It's all about your idea is good. You already have a good idea, or you probably wouldn't be writing a grant. Can you support that idea? Both, does the idea work? Can you get a body of data that shows that idea works? And then, are you the person that should be doing it? And why are you the person that should be doing it? So for me, when I was writing grants, they kind of write themselves, because it becomes, okay, antibiotic resistance is killing people, SARS, killing people, cancer, killing people. It's pretty easy to say why I need to look at this. Then I can come and say, all right, we need to look at it from a computational approach. And here's how my approach is different and better than these other approaches. And here's why I'm the best person to conduct that approach, because I was the one who developed it. And so it should be somewhat organically. And the grants that I write that fail are always the ones where they weren't organic, where it didn't feel right, where it wasn't flowing, where it wasn't already laid out. So if you're really struggling with the logic of those things, you might want to rethink that part, because the reader's going to notice it and they're going to reject your grant. So just think about that. So publicly available data, fine. Privately available data, fine. Collaborator data, fine. just make sure the collaborator has the backing, they have the credentials and the publications to say that they generate the data properly. That's what they'll need there. Hopefully I answered your question.
Yeah, thank you so
Okay.
much.
Any other questions? I personally have used nothing but publicly available data for grant ideas. Now, the published papers, I have had to do some of the wet bench biology as validation. So like when I go for a grant in a new area, it will have publicly available data analyzed for proof of concept that my idea works. But then I also have papers on different topics that show the approach worked with a wet bench validation, with a Petri dish validation or what have you. And so then people will see, oh, well, Laura's done this with the same approach in the past and validated it in the wet bench. And she's got data for the computer that it's going to work. Yeah, I think we're going to fund this because there's a good chance it's going to work in the lab now. So you see the logic progression. That's really important with grants.
Thank you so much, ma'am,
Yeah,
for sharing your
anytime.
experience and inspiring us all. I hope participants got a lot to learn from it. Thank you, everyone. I have an announcement to make. We are launching our next paid workshop on protein structure, which will cover bioinformatics methods in determination, production, modeling, docking, simulation, and visualization and protein structure. Kindly register yourself on www.scholareducation.org. Yes. Questions?
Ma'am, what will be the price for a registration of this amount? How much amount is it?
1200.
1200, right?
Yep.
Okay.
Recorded or all the details will send to your email address.
Okay. Okay.
Yeah, it
okay,
was
just
written in the also.
how many days it will?
For 10 days
Okay.
from 16 May to 25 May at 6 p.m. to 7 p.m.
Okay.
No more questions. So I would like to thank Dr. Laura Harris for this wonderful presentation. I think everyone could relate to your journey, and you have covered a lot about starting in teaching and then going back to research and coming back to research, going to teaching and research back again, and now to industry. So you have a really, really inspiring journey, and I really, really thank to you for coming to this platform and sharing your journey. Thank you very much, ma'am.
Thanks for the invite. Have a great day, all.
You too. Thank you. Thank you all the participants.
Hello.
Hello. Yes.
Sir,